very first, let's try to understand positions. If we hit an upper line, okay, can we say this is nothing but your 0, 1, 3, 10, last is okay. This is what we have given number line. So the question we have given, the robot is at 4. This robot, what is at 4? Mark this. This is what a position at robot. Okay, this position. Okay, R we can. The wall we have given is 1 and 10. Wall is at 1, 10. What the question is saying that the robot range we can say that can cover even distance. So from here, 4 we can say 4, 3, what 1. He can go from what covers the range from here to, and similarly is the from the left side. Talk about right side. What is the robot range? Okay, try to understand. So when we say 4 minus 3 for the left range, 4 plus 3 the right range, the range of the robot. If anything completes 1 to 7, if any number of ball is there in this range, robot can hit left side, the right side. Okay, can we say that we have only one wall is here in this range? W, that one. That is why robot can, okay, try to hit the bullet. But if he tried, next wall we have at 10. If he try to the right side, he cannot reach because the range is at. Okay, hope you understand the problem. Let's try to understand another example. Second, let's try to see example number 2. Right, we have seen the robot can hit only one wall at. Okay, now try to understand example number 2. So robot is at 10 and 2, and the walls are 5 to 7. Okay, means what is common here? The wall and robot both are at which position? At 2. You can say we have robot here and wall both is at the same position. Okay, next robot is at, okay, and the wall positioner have seen 2, 5 at 7. What we have distance for 10, 5, 2 is 1. Okay, if you talk about the range robot, the range robot, left side, right side, we say that. Now let's talk about range for robot. So this robot have a distance 5, right, and 10 minus 5 can reach 2. Okay, this is what we have the following statement. Now the robot can hit the wall or not. Okay, so when we talk about the robot mark is robot 1, robot 1, if we travel, try to hit in the left side, he can hit how many walls? Think he is already at where? At 2, and there is a wall. We can say he can hit one wall. So then that wall is done. But when he try this side, right side, he cannot do because there is no wall. And this wall has already destroyed. You can say only one wall can be destroyed by the robot 1. Next, try to understand for the robot 2. When robot 2 try to hit, this is the range. In the range, we have 2 wall is there at 5 and 6. So there is 2 wall that robot 2 can hit. How many? 2 walls are there. The robot 2 that can hit. The sum get 3. Why we are seeing Coming 3. I hope you understands. If you have any doubt, till now, please ping me the comment box that you understand the example or not. So, if we understand the problem statement, we can say our intuition is always count the walls, right, at the robot position immediately when he hits, right? Then we have to handle the gaps between the robot, right? Have to tell the gaps, what the gaps are there, right? Between the robot and that, deciding whether each robot will shoots the left or the right, right? We can say for this robot, it doesn't have the boundary in the right side, right? And we can say those things we have to cover, those edge cases we have to cover. So can we say the robot, you can say the leftmost robot having the best suit, right? The left side, the rightmost, we can say the best to suit in the right side. There will be some middle positions, right, where the robot will decide. So there will be a DP that decide optimal to maximize the destroyed walls without double counting, right? Because we know that this has destroyed, right? We don't need to count again, right? That I think you are understood. Okay, let's try to understand the approach. So there is only one core challenge, is that if two robots are separated by the gaps, okay, okay. So if two robots are separated by the gaps, only walls in that gap can be destroyed by those two robots, right? But in this case, that this robot doesn't have the range, but this robot has range, he can hit it, right? So we can say the left robot may shoot the right side into the gap, may, but in this case it is not happening, but he can, if the range is there, he can hit, right? Similarly, the right robot may shoot the left into the gap, right? Or we also say there will be a chance when both may overlap and destroy some walls, right? This is the challenge we have. Another challenge we can say, some walls are there, right? And some walls sits exactly at the same position at the robot position, as we can see here. So there are always it can be destroyed. So this is the base count we can, when both positions are same. Understand? So you got the base count. So you have to check if the robot sits at the wall position, or you can say wall sits exactly at the robot position. So it can be always destroyed, and this is what we can say is the base count, right, that we have seen for the robot one. We need to make smarter decision for each step. So should we let the left robot should right, or the uh, right robot should left, or both, in the case like when we the overlap, handled carefully. So all the things we have to take care of. I hope you understand. Very first, we have to normalize the inputs. What are the inputs we have given, that we have to check? So if you talk about what are the pairs we have, the pairs is we have the robot we have and the distance. So we have to take the pair, because we have to normalize this, can say inputs. So we'll say we'll take the robot and the distance, right? And we'll sort by the robot position, and then we'll sort the wall position, and then we'll count the base count like we have done for the here. The base count, the wall are sitting directly on the same position at the robot. The remaining walls will handle using the robot sorts, either right one will suit, the left one will. Okay. Also check wall position, the boundaries, the leftmost boundary, which we can say only covers the its left side. Talk about the right side, rightmost robot will fire the our last, we can say, in the this side. So we can say this is our L0, our R lasts. Okay. So the leftmost robot fire L0, only it can cover the walls the left side, right? It's left side. Talk about R last, side the right side think, right? We cover the walls for the its sides. Okay, the left or right. Right. Okay. Now think about the walls between the robot. Okay, let's suppose there is some. Let's suppose this is P and Q. Okay, so two robots consecutive are sitting. Let's take these two consecutive robots that sits, and there are two position. So these two position where robot are sitting. We say that. So wall can lie in between. What are the position can be possible? I clean it. Okay, so let's try to understand. If this is your robot one, robot one is P, you can say P, and this is at Q. Right? So the wall can lie in between these. Can we say that? So we'll say A at J. The wall destroyed if P fires. P fires where? Right side. Okay. Then will be B J, and this is the wall fires if Q fires left. Understand? And then will be position AB, that is called J, wall double counted if both fires in the same zone, right? The same zone. Can we say that? There is a possibility. So walls, the gap can be covered by only P, Q, but both, for both, this subtract will be, or we can overlap, right? Because if both try to, suppose for in this range, if he also have the same range, right, he can travel to here, right? So for this case, if he is hitting this and he is also hitting this, so this wall will be overlapped by the shooting. Okay, so that we have to understand. Now think the DP concept, dynamic programming. Now imagine we process the robot from left to right. So there will be TP at 0, and we can see the best result so far if the current gap writes the robot doesn't suit the right, and TP at will take 1. This is the best result. So if the current gap right robot doesn't suit the will suit the right side. Understand? Two things will take, means the TP at 0, we will keep the best result if the current gaps we can say of the right robot doesn't suit. This is for the if it suits. Then we have to take the transitions for the DP. So this is what we understand, right? Then we have the transition, right? If the right robot doesn't suit the right, we can still add BJ, right? We can still, because the left shot from the next robot we can add. But if the robot suits the right, if this is not suits, so we can add the AJ, correct? And then we can add the BJ, sorry, BJ. When we talk about it will suit, if it is not suits, then we'll add the BJ. If it will suit, then we can add the AJ, right? But there will be an overlap with the, that we have to, we should must check if this overlapping or not. So there will be we have to find all the combinations without double counting. Okay, that is what we have to do. Means finally we can say we have to take the max DPS states, right? That we can say for this case. Then we'll add our last, the wall destroyed by the last shooting fire by the right, the base that we have seen. I move this one, base wall at the position of the robots we have seen. Okay, let's try to understand the code. And clearly I tried everything, make you understood. Very first thing, I have given the robot, right? You have to pair the robot with their distance, robot position. See that? How we will do that? So let's suppose we will keep all the robot information in place. Is called the list of the robot. Okay. Then for each uh, robot, right? Because this is the number of robots we have. So we'll go for all the robots. We'll keep adding all the its information. Means we'll add the robot sense in one pair. I hope you understand this. Okay. Then we'll sort it like this, the collection frame. Okay. Now I have to take two things: what positions, next distance, and the cover. How much robot can cover. This is what we will do. Right? And we can next we have to do, we have to sort the wall and we have to separate the wall at the robot position. How we are going to do? Very first, we'll do array dot sort. We can sort the array and we can set the wall, right? We'll take the robot set. Time will keep not duplicate. So overlapping will not. So we'll take the remaining walls and we'll find the walls at the robot position. If that is the case, that is become the base case. We'll say start will start from 0. All the base cases, the walls at the robot position will keep increasing the base. Plus one will else the remaining wall. Compute in the remaining wall. So we have to compute on the remaining wall. Say this is the position of wall's position. Now we have to check the boundary conditions. The wait, right? The in function, right, where we can find lower bound, the upper bound. Then we'll check left most robot firing left and similar rightmost robot firing. Okay. Then we'll compute left and right overlap, left only, right only, and the cases will. Once this is done, have to all here. Remember, as I told you. Okay. Left robot, there will be the check for the start index. Where we will start index, the end index, in both, right? And we'll check the condition. If it is overlapping, this will otherwise there will be the left, right, and overlap will compute, right? Find the max. Is max. Similarly, we know the deep overlap and non-overlap. Continue these three things. Overlap, next overlap, next no. Okay. Once these are done, just need to find the contribution, the base wall. The EP at no overlap with overlap, rightmost all will add here and we'll find the max. Just to the base that robot at the same position, that will be base, add into the max, right? Remember the example 2, right? One is this is what one positions. Okay. So that's all I have in this video. Let me know in the comment section that you understood. Next one, please hit subscribe this channel. Any suggestions in the comment box? Improving funda will keep helping journey. Check out the courses description section. Characters. Anyways, thank you for watching this video. Like, subscribe.